Assalamualaikum. So what if I told you that almost every machine that have a mechanical move is powered by the same thing, which is called DC motor? Hello, my name is Ahmad Kim bin Ibrahim and my metric number is 212010864. And my partner is Adam Lemat Nasir. His metric number is 212010930. The presentation for today is for electrical technology. The title is DC machine and DC motor. So what is a DC motor? DC motor is a motor which convert the direct current into the mechanical work. It works on the principle of Lorentz law, which states that the current carrying conductor placed in the magnetic and electric field experience a force. So, for further ado, we'll move to the part and the design. First of all, we have stator, which carries the field winding and post. The stator together with the rotor constitute the magnetic circuit or core of the machine. The design is a hollow cylinder. Next is the terminal that have a negative and positive to connect the negative wire and the positive wire. Either we want the motor to rotate clockwise or the motor to rotate counterclockwise. Next, we have the brush that are attached to the commutator as a bridge to deliver the electrical energy from the supply circuit to the rotor. Fourth is shaft. The winding and the commutator rotate the shaft, which at the center of the motor, made of a hardened steel, usually steel, to withstand the loads of the application. Next, we have commutator. Commutator has a form of a split ring. They are usually made from copper and they are basically split into two. But depending on the number of armature, they usually split into more parts. Next is the armature winding. They are used to energize the static magnetic field in the rotor. And next is field winding. They are usually made from the copper wire and circle around the pull shoes. They are used to energize the static magnetic field in the stator. Next is the magnets. The magnet used in DC we refer as the permanent magnets, which means that their magnetic field is always active. That it is the same principle as the magnet, which the opposite side of the magnet attract while the similar ends repel. The most powerful part of a magnetic field is at its end. Two magnets create a very strong field. This is why two magnets are included in a DC motor around the rotor such that the strong magnetic field passes through the rotor. Last is the rotor. It is made of multiple discs that are isolated from each other by laminated sheet. The multiple discs will prevent the creation of a large LG current. The LG current are the reason why the plates are isolated, but there are still smaller presence of the LG current but it will not interfere with the operation of the motor because they are necessary part of the motor operation. Next, we will move to the operation of the DC motor. We already know what is DC motor and what is the part. So how does it work? The basic working principle of the DC motor is whenever a current carrying conductor is placed in a magnetic field, it experiences a mechanical force. So the simple rule for the DC motor is Fleming's left-hand rule, and its magnitude is given by F equal to BIL, where B is magnetic flux density, I is the current, and L is the length of the conductor within the magnetic field. Next is the type of the motor, DC. We have four, which is the first one is permanent magnet DC motor. They use the permanent magnet to create field flux. This type of DC motor provides good starting torque and has a good speed regulation, but they are limited, so they typically found on low horsepower application. Next is the series DC motor. The field is wound with a few turns of a large wire carrying the full armature current. Typically, DC motor create a large amount of starting torque but cannot regulate speed and can be damaged by the running with no loops. The third one is the shunt DC motor. The field is connected in parallel with the armature winding. They offer great speed regulation due to the fact that the shunt feet can be excited separately from the armature winding, which also offers simplified reversing controls. And the last one is compound DC motor. Most likely like the shunt DC motor that have a separately excited shunt field. Compound DC motor have good starting torque but may experience control problem in the variable speed drive application. That's all from me. I will pass on to my partner Muhammad Adam to continue this presentation with DC motor speed control.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adam bin Muhammad Nasir. My number matrix is 2120109330. Now it's my turn to continue this presentation. DC motor speed control. Often we want to control the speed of a DC motor on demand. This intentional change of drive speed is known as speed control of a DC motor. We can control the speed of DC motor manually or through an automatic control device. This is different to speed regulation, where the speed can regulate against the natural change in speed due to change in the load on the shaft. Practical of speed control. The speed of a DC motor N is equal to N K V minus IARA, where K is a constant. This implies three things. Speed of the motor is directly proportional to supply voltage. The speed of the motor is inversely proportional to armature voltage drop. The motor speed inversely proportional to the flux due to the field windings. Thus, the speed of a DC motor can control in three ways. First, by varying the flux and by varying the current through field windings. Second, by varying the armature voltage and the armature resistance. And the third one, through the supply voltage. First thing first, flux control method. Due to the field winding, the magnetic flux varies in order to vary the speed of the motor. As the magnetic flux depends on the current flowing through the field winding, it changes by varying the current through the field winding. This can achieve using a variable resistor in a series with the field winding resistor. Initially, when the variable resistor keeps at its minimum position, the rate current flows through the field winding due to a rate supply voltage, and as a result, the speed is kept normal. When the resistance increases gradually, the current through the field winding decreases. This in turn decreases the flux produced. Thus, the speed of the motor increases beyond its normal value. Next, armature control method. The controlling of armature resistance controls the voltage drop across the armature. With this method, the speed of the DC motor can control. This method also uses a variable resistor in series with the armature. When the variable resistor reaches its minimum value, the armature resistance is at normal one. Therefore, the armature voltage drops. When the resistance value gradually increases, the voltage across the armature decreases. This in turn leads to decrease in the speed of the motor. In this way, this method achieves the speed of the motor below its normal range. Third, voltage control method. Both the above mentioned methods cannot provide speed control in the desirable range. Moreover, the flux control method can affect commutation, whereas the armature control method involves huge power loss due to its usage of resistor in series with the armature. Therefore, a different method is often desirable, the one that controls the supply voltage to control the motor speed. In such a method, The field winding receives a fixed voltage and the armature gets a variable voltage. One such technique of voltage control method involves the use of a switchgear mechanism to provide a variable voltage to the armature. Another one uses a AC motor driven generator to provide variable voltage to the armature. Another one uses a AC motor driven generator to provide variable voltage to the armature. Apart from these two techniques, the most widely used technique is the use of pulse width modulation to achieve speed control of a DC motor. PWM involves application of varying width of pulse to the motor driver to control the voltage applied to the motor. This method proved to be very efficient as the power loss keeps at minimum and its application of varying width of pulse to the motor driver to control the voltage applied to the motor. This method proved to be very efficient as the power loss keeps at minimum and it doesn't involve the use of any complex equipment. PWM is achieved by varying the pulse applied to the enable pin of the motor driver IC to control the applied voltage of the motor. The variation of pulse is done by the microcontroller with the input signal from the push buttons. Here is the benefit of using the Ward-Leonard technique for DC motor speed control. First, in both directions, one can control the speed of the device in a smooth manner for an extended range. Second, this technique has in-street braking ability. Third, the trailing reactive volt amperes are counterbalanced through a drive and the extensively excited synchronous motor acts as the drive, so there will be an increment in the power factor. Fourth, when there is a flashing load, the drive motor is the induction motor having a flywheel, which is used to lessen the flashing load to a minimal level. The disadvantage of Ward-Leonard technique. First, as because this technique has a set of motor and generator, so the cost is more. The device is complicated to design and has heavy weight to need more space for installation. Requires regular maintenance and foundation is not cost effective. More noise is generated. Starting methods of DC motor. As a direct consequence of the two above mentioned facts, high starting current and high starting torque of DC motor, the entire motoring system can undergo a total disarray and leads towards into an engineering massacre and non-functionality. To prevent such an incident from occurring, several starting methods of DC motor has been adopted. The main principle of this being the addition of external electrical resistance rates to the armature winding so as to increase the effective resistance to Ra plus Rext, thus limiting the armature current to the rate value. The new value of starting armature current is desirable low and is given by Ia equals to E divided by Ra plus Rext. Countering the supply voltage, resulting in the decrease of the net working voltage. Thus now, Ia equals to E minus Eb divided by Ra plus Rext. At this moment, to the maintain the armature current to its rate value, Rext is progressively decreased unless it's made zero when the back produce is at its maximum. This regulation of the external electrical resistance in case of the starting of DC motor is facilitated by means of the starter. Types of starter used in the industry today can be illustrated as 3-point starter. The internal wiring of a 3-point starter is as shown in the figure below. When the connected DC motor is to be started, the lever is turned gradually to the right. When the lever touches point 1, the field winding gets directly connected across the supply and the armature winding gets connected with resistance R1 to R5 in series. During starting, full resistance is added in series with the armature winding. Then, as the lever is moved further, the resistance is gradually cut out from the armature circuit. Now, as the lever reaches to position 6, all the resistance is cut out from the armature circuit and armature get directly connected across the supply. The electromagnet holds the level at this position. This electromagnet releases the level when there is no supply voltage. 4-point starter. The main difference between a 3-point starter and a 4-point starter is that the no voltage coil is not connected in series with the field coil. The field winding gets directly connected to the supply as the level moves touching the brass. The no voltage coil is connected with a current limiting resistance. This arrangement ensures that any change of current in the shunt field does not affect the current through hold-on coil at all. Now, finally, we are on the last slide. The conclusion is, first thing first, a DC motor or direct current motor is an electrical machine that transforms electrical energy into mechanical energy by creating a magnetic field that is powered by direct current. Second, one of the reasons that DC motors are preferred over the other types of motor ability to precision control their speed, which is necessity for industrial machinery. Third, two of the main advantages of DC motor over alternating current AC motor are how easy they are to install and that they require little maintenance. Fourth, a DC motor is based on the idea that when a current carrying conductor is placed in a magnetic field, it produces mechanical force. And the last one, there is a limitless number of applications. There is a limitless number of applications where DC motors are used since they have a high starting torque compared to induction motors. And that brings us to the end. I would like to thank you for your time and attention. Thank you so much for your interest and attention. Hope you can enjoy our group presentation. Goodbye.